So in this video, we're going to take a look at the second part of the review for the final exam. We went over questions 1 through 11 in the first video. Here we're going to go over the chapter 2 review with questions 12 through 20. And just like with the first video, I put the section where each one of these problems comes from. I highlighted in yellow what we're looking for and what type of problem it is, and in green are the values that will be going in the formulas. So for this first one, this is a simple interest problem. I am looking for the total value in the account. That's why I chose that formula. The green values that are going into the formula, I made a deposit of $2,000. I have an interest rate of 0.35. Don't forget to turn that into a decimal. I'm leaving it sit in the bank for 5 years. So I have $2,000. 1 plus 0.035 times 5 is 175, and when I multiply those two together, I would get 2350. My answer is choice B. So that's how we're going to break these problems down. See what I mean with the next one. I'm going to skip over question 13. Let's scoot on down to question 14. So here are all the highlighted values. What I have is from section 2.4 because this is a compound interest problem. I want to see how much I'm going to have in my account if I start out with $2,500 from my summer job. So I'm a saver and I'm going to put that in the account. I'm going to earn 3.7%. It is going to be compounded annually. There is my 1. I'm going to let my money sit in the bank for 4 years. If I have the right formula, I put the values in correctly. From here, it's going to be calculator time, 2,500, 1.037 raised to the 4th power. So my future amount is 2,500, and what I'm going to do is take out my calculator for that 1.037 and raise that value to the 4th power. That's how I do it on my graphing calculator. Remember, with a cell phone, you probably have a X to the Y key. You're going to come up with this number at 1.1564. So the future amount I'm going to turn my $2,500 into is $2,891. I'm going to choose my closest answer. My rounding, I was off by a nickel. That's fine. Always go for your closest value. Number 15 is basically the exact same problem. I have a compound interest problem, so that throws me right to this formula. I want to see the future value A. If I start out with $2,000 in this account, I get 4.1% interest. This is compounded monthly, so my N is going to be 12. I'm going to let that sit in the bank for 4 years as well. There are all of my values plugged into the formula. Now again, it's just calculator time. I'm going to say 1 plus that value 0.041 over 12, 0.003416. 12 times 4 is 48. So my future amount is $2,000. And then again, going to my calculator, 1.0033416 raised to the 48th power is 1.778. Multiply the last two values together, I would come up with 2355.60. Off by 17 cents because of rounding. Again, always go for your closest answer. So there is number 15. Let's take a look at number 16. This is an effective interest problem, which is also out of section 2.4. So what I have for my effective interest here is I have a nominal interest rate of 4%. It is compounded monthly. My N is 12. My T in this equation is always 1. I'm going to subtract 1 at the end, so my T is 1. So what I have is 1.04 divided by 12 is 0.0333 raised to the 12th power minus 1. So in my calculator, I have 1.00333 raised to the 12th power 1.0407. 1.0407. I'm going to subtract 1. There's what I have for the decimal. Remember, this is going to be a percent, so I have to move the decimal over twice or multiply by 100, and I have a value, an effective interest rate of 4.07%. Number 17, what is the present value? A savings bond. This is out of section 2.5. This is a compound problem. Right away, I see that, and I run back to this formula. There's where I get started with this. This bond, the future value is going to be worth $10,000. The present value is P, how much I need to buy this bond for today. The interest rate is 5.3%. My money is going to be compounded annually. I'm going to let it sit in the bank for 10 years. So here is my 10-year value right there. So there are all of my givens from the equation into my formula. So I have 10,000 is equal to P times 1.035 raised to the 10th. I have 10,000 equal to P, 1.053 raised to the 10th is 1.676. I'm going to divide through by. I'm going to cancel, and my P, how much I need to buy today, this bond for, $59.66.45. So that one wasn't in multiple choice format either. All of them will be on your final exam. Number 18, there's no calculating here. This is more conceptual problem. I'll show you what's going on here. John has a goal of reaching $10,000. There are 2 banks and 2 cases that he can choose from. The first bank says, our interest rate is 4.6%. John says, my goal is $10,000. He has to deposit a certain amount of money. The second bank across the street, for a second case, his goal is still $10,000. This bank offers him an interest rate of 4.7%. His P, the value, his present value that he needs to buy the bond for today, is that higher or lower? It's going to be lower, and here's why. His higher interest rate makes up for a little less money if he buys the bond today at 4.7%. Going to get to his goal, it's going to cost him less because that higher interest rate is going to make that little bit of less money grow more than 4.6%. Number 19, here is one of the problems where we break down our monthly payment to attack the interest that we incur during a loan, and we pay down the principal, the amount that we borrowed over time. So here's how we're going to do this one. My interest portion of this monthly payment, I'm going to take $105,000 $683.56. This value right here, how much I owe on the loan today. I'm going to multiply it by my interest rate, and I am looking at just 1 month. So this was a $125,000 loan initially. It's been paid down to this value. That's how much I owe on the interest rate for 1 month. This value is $506.40. That part of the monthly payment goes down towards paying the interest. What's left over towards the loan amount, you take the monthly payment, subtract out the value that went to the interest. Left over is the value that you have for the principal. There's what you would have for number 19. The last one that we have for number 20 is a monthly payment problem. So I wrote down the formula for monthly payment. What I'm going to do here is plug in these values for this car loan. So I have $21,600 for the amount that I'm going to borrow. The interest rate is 4.5%. My N is always going to be 12 in this problem because we're looking at a monthly payment. Putting the values in downstairs in my denominator. Don't forget my negative exponent. N is 12. You have 4 years to pay the loan back. So there are all of the values into that beastly formula. Make this a little less intimidating. Remember, I'm going to block out everything that's going on downstairs in the denominator. Just work with the top part first. That's going to make life a little less intimidating. So I have 81 upstairs. It's already starting to clean up. Now, downstairs, I have 1 minus 1.045 divided by 12 is 0.00375. I'm going to say negative 12 times 4, which is negative 48. So from here, I have 81 over 1 minus this value in my calculator is 0.8356. So I have $81, almost done, divided by 0.1644. My monthly payment is $492.70. There's how we do that one from start to finish. I was off by 14 cents, a rounding error with all of these rounding values there. There's how we do that. The next video will be on Chapter 3 review on statistics.